I'm gonna build an electromagnet by a battery in this video. I chose this experiment to show we can build our own magnet by simple stuff and how fun it is. The mathematical formula that describes the function of a magnet is called Ampere's law. It says that the strength of the field times the gap is equal to the number of turns in the coil times a current times a constant called mu. The above equation tells us for a given current and number of turns how much magnetic field we will get. Another famous law called Ohm's law tells us the relationship between ohms, volts, and resistance. Volts equal to ohms times resistance. The coil should be made so it has a voltage drop equal to what your battery can put out at the best rate of discharge. A piece of copper has resistance which can be determined from the following formula. I will create an electromagnet by two different types of batteries such as C-cell and D-cell, copper wire, a bolt, and rubber bands. And then I tested with some paper clips. AAA, AA, C, D batteries all are rated at 1.5 volts. But besides the difference in physical size, there is a big difference between them all. In an electrical circuit or device, there are two really important things, voltage and current. The D-size battery will deliver more current than C, AA, and AAA size battery. We get the most current from a battery when it's fully charged. Also, it's a good idea not to withdraw the current at too high a rate. Solid copper wire is better because it can usually carry more current. It's best to have a large amount of copper to keep the resistance down. It's also good to have a lot of turns to make better use of the available current. Copper has the lowest resistance at room temperature, so it's a great choice. It's very important to insulate the wire, otherwise it will short out the turns and the magnet will be ineffective. We have to find out the optimum discharge current to get the best battery life. Also, I have to optimize my magnet design, especially the coil, to match my battery. The main objective of this experiment after building a magnet is compare the different batteries and see how they act differently as a magnet. I tried to make a magnet first with a D-cell battery and expected to get a stronger magnet than C-cell battery. Because the D-size battery is bigger and delivers more current than the C, but contrary to my expectations, C-cell makes a stronger magnet than D-cell. Ampere's law tells us how much field we get for a given current and turns count. Ohm's law tells us about the voltage drop at the current we want for a given resistance, and the formula for resistance tells us the resistance of the wire that we choose. Now we have to optimize our magnet design. The trick is to make the coil so it discharges the battery efficiently at its rated voltage. First, I'm building a lever with a strong paper board and a cutter, then connected by a screw to hold and move my magnet. So I pick a copper wire, match the voltage drop at say 5 amps to the available 12 volts, and we have our coil. Our magnet depends on how many turns we get. If the field is too low, then we need more turns or higher current. I just adjust the size of wire to match the required amps and the voltage at the required turns to what the battery can do. I attach my coil to the lever to have the best result. After making a holder by binder clips of the battery for the 120 amps hour battery, it's best to withdraw only 60 and then stop and recharge. It's a good rule of thumb for all deep cycle batteries to not take out more than half the rated charge. This way, they last a very long time. Other common batteries that I consider are the D cells that I use here. They are rated at 1.5 volts. They are only good for currents of a few milliamps. We can get more current by putting these batteries in parallel. If we need more voltage, we can put them in series, but it's not necessary in this experiment. As you can see, the magnet is made and works perfectly, and it attracts about 3 to 4 paper clips. Then I installed the C-cell battery to see what is the difference between them. Nice, this one is much stronger than a D-cell's battery. It can attract 6 to 7 paper clips. Both batteries, D and C cells, get hot after being connected with copper wire. That means currents are delivered. One inevitable source of error includes discharging the battery fastly by copper wire that decreases the magnet power. Factors that affect the strength of electromagnets are the nature of the battery material, strength of the current passing through the battery, the number of turns of wire on the screw, and the voltage and size of the battery. The D-size battery delivers more current than the C-size battery, although it has the same voltage. A C-cell battery makes a stronger magnet than a D-cell. I used 3 sources to make this video. Thank you for watching.